Look at this problem here. A sample of gas collected at 50 degrees Celsius occupies a volume of 1 liter. The wet gas exerts a pressure of 1 atmosphere. When dried, the sample occupies 1 liter and exerts a pressure of 1 atmosphere at 95 degrees Celsius. What is the vapor pressure of water at 50 degrees Celsius? Okay, let me look at this problem. Let's first see what we're given. So we're told that we have a temperature of 50 degrees Celsius. So this is our T1, which is equal to 50 degrees Celsius. A volume, which is our first volume that we're coming to. So we have a volume of 1 liter. It says the wet gas exerts a pressure of 1 atmosphere. So this statement, this question right here is crucial. This statement is crucial because we're told that we have a pressure that's equal to 1 atmosphere. So, and it's wet, which means that we have to take into the account of the pressure, the total pressure, which is going to be equal to whatever the pressure of the gas is plus the pressure of the water. So the total pressure will be equal to 1 atmosphere, which is equal to the pressure of the gas plus the pressure of the H2O, water. It says when dry, the sample occupies a volume of 1 liter, so our V2 is equal to 1 liter, and exerts a pressure, our P2 is equal to 1 atmosphere, and our T2 is equal to 95 degrees Celsius. So looking at this equation, we see that this is a combined gas law problem because we have T1, V1, we have our pressure, but this isn't our P1, we have V2, P2, and T2, and we need to be able to determine what's the pressure, so what's the initial pressure, which is P1 at 50 degrees Celsius, because we have everything else at P1, but we don't. We have everything else in terms of the initials, 50 degrees Celsius and volume, but we don't know what the initial pressure is, but we are told the total pressure, which is 1 atmosphere, and the total pressure is equal to the pressure of the gas, whatever the gas is, plus the pressure of the water. So in this equation, what we want to be able to solve for is our P1. So we have P1 V1 over T1 is equal to P2 V2 over T2. Knowing that, we then can solve this equation for P1, which would give us that P1 would be equal to um, P2 V2 over T2 times all of this is going to be multiplied times T1 over V1. We would know that. Um, so let's go substitute back into the equation. Alright, the equation that we're going to have is P1 is going to be equal to P2V2 over T2, and all of this is going to be multiplied times T1 over V1. We know that our T1 is equal to 50 degrees Celsius. We can convert that to Kelvin. That's going to give us 323 K. We know that our V1 is equal to 1 liter. We know that our P1 is what's in question. We know that our P2 is equal to 1 atmosphere. We know that our V2 is equal to 1 liter, and we know that our T2 is equal to 95 degrees Celsius plus 273, which gives us a temperature of 368 Kelvin. So we take these variables and substitute them back into the equation, which means that P1 would be equal to P2 is 1, volume V2 is 1, T1 is 323, T2 is 368, and V1 is 1 liter. When we do our calculations, we will get 0.877 atmospheres. So our volume, or our initial pressure, is 8.77 atmosphere. But the question asks us, what is the vapor pressure of water at 50 degrees Celsius? So we have to go one step further. Remember, we were told that PT is equal to the pressure of the gas plus the pressure of the water. That's the water vapor. So we know that the total pressure was equal to 1. So we know that PT is equal to 1. And we know what the pressure of the gas is, because the pressure of the gas is equal to what our P1 was, our initial pressure. So we can solve this equation by saying P of total minus the P of gas is equal to the pressure of the water. So if we have 1 minus P1 is equal to 0, or pressure of the gas is 0.877. So minus 0.877, this will give us the pressure of the water, which is 0.122. So the vapor pressure of the water is 0.122 at 50 degrees Celsius. Okay, that's a wrap.